What we're looking at here is a bracket that goes on an outboard motor for the steering arms to connect to. And what I need to do is to make something like this, only slightly different. This one has been cut from stainless steel. Looks about the same as what we're working with, 10mm thick. Laser cut, I think. It doesn't fit the motor. And the customers brought this in, but it doesn't fit their motors. It's got 4 bolt holes here. And their one needs this pattern. And they're going from this style, the single-sided push and pull. I don't know what they are, whether they're just done by cables or hydraulic actuators or whatever. It's a pretty beefy motor, I believe. But anyway, they want to switch from that to something more like this style. And they've given us a pattern template cut out of a piece of plywood. So that is what we've got to try and do. Cut out this stainless piece of plate we've got here. To one side, we don't really need that. But it does kind of demonstrate that the overall shape of the thing doesn't really matter. The positions of the holes are going to count, and the shape here can be whatever we like, really. So they said we can cut this corner off if that makes life easier, which it will do. Yeah, so far I've just marked the pivot holes at each end. Kind of assumed that they're meant to be 18 inches apart. I don't even know if that's critical. Mark the centre hole that corresponds with that, and I think what I'm going to do now is put this other piece in position here. Try and locate the centre hole with the mark I've made on the plate, and then I can mark out these holes. And what I'll also do, I think, is I shall drill some holes on the corners of the shape that I'm going to be cutting out. I'm cutting this out with a cutting disc on an angle grinder, which is a crazy way of doing it, really. But my only other option would be to do it on a bandsaw, and cutting 10mm plate on a bandsaw would be, oh dear, such a mission. I don't have a decent blade. And this is still a heavy old lump of stainless. I don't fancy lifting it again and trying to manoeuvre it on the table of the bandsaw. So yeah, we're going to have fun trying to do this with a cut-off disc and an angle grinder. Also, what I think I will do is I will cut these twiggly bits off of here, because there is such a bend on this piece that it is stopping the plate from laying flat. So yeah, so I shall cut these thin pieces off. They're going to be no good for anything, and then continue with my marking out down here. Just having another look at the bend on this. That is crazy. And that's just the stresses in the metal that's done that. It hasn't been bent. And you can see the bend of the other piece on the other side curling upwards. Amazing. And this piece here, this corner, is supposed to be the same height, level as that. Incredible. And yeah, the curve on this piece here, plus it's got some holes in one side, which is a bit of a nuisance. So it would have been nice to have cut our piece out of here, because it almost fits. Looks ideal. but there's holes here which are in the way, and I can't get, wherever I manoeuvre this, there's always one that's going to be in the piece that we want to cut out. Plus, it's got this curve on it. I might be able to flatten it out if I cut it out from there, but I think I'm going to be better off cutting it out of this. The piece seems to be flat in this direction, so I think that'll be better. And now this should lay on the table a bit better. Yeah, it's a bit more like it. We've still got this curve here though, look. Which, as I say, is why I'm not going to cut the piece out of that, even if it didn't have these holes in. Right, back to marking. Don't know if we can see inside those holes, but I think they're lined up okay. Markings look good. And I just flipped this plate over to make sure it was symmetrical, and it seems to be. Or the shape isn't, but the way the holes are marked out seems to be good. I guess that's the only thing that counts. So I might trace some lines off of this as well, and then flip it over. Take a kind of an average of the shape of the thing. So having got the holes just marked out with a pencil through the template of the old plate, all I'm going to do now is just eye up the middle and punch a spot, and that's a little bit off, so I'll just drag that back over that way a smidge. Oops. That looks a bit more like it. Yeah, I think so. It'll be interesting to measure this, because you'd think there would be like an exact size distance between the holes. Four and a quarter inches. Yeah, it could be. I think outboard motors are an American thing. I think the standards are American, so they're likely to all be measured in inches. I could have that totally wrong, but I'm kind of guessing that might be right. So 4 and a quarter, that, I think we go with that, stick at that. And this one, oh, that is not going to be anything in particular. And that's looking like that might be 7 inches. And we've got a little bit less than that at the minute, which is no kind of metric size. 177. Can't imagine anybody designing that. It's a bit hard to see exactly, but I think I've got these holes pretty much marked out okay. A better way of doing it would have been to have clamped this piece to the plate that I'm trying to mark and mark them out with transfer punches, punches to the centre pot, nice fit in this hole, just pop into the bottom. I haven't got one the right size, so I had to make do with what I've got rather than going and making up a transfer punch. But I think these are okay. So now, let's get that out of the way. I'm going to mark a line here. Damn stainless steel. I think that drill's blunt already. Doesn't look too bad. Let's get the eyeglass out, I can't see it properly. Need some cobalt ones for stainless. And the idea is, it's really hard to drill holes in. It's tough stuff like stainless steel with a pistol drill. So I usually try to start off with something small. This is about, I don't know, 4.5 or something. And then we'll try and open it out to, I don't know, maybe 6 or 7, 8 perhaps. Got this tin coated drill here, we'll give this a go. Okay. Wow. Literally through. Oh, that's shockingly heavy. Wow. That is struggling, wow. So, slightest sign of wear on the corner of the tip of the drill. No, it's getting there. Doesn't want to. Oh, stainless is such a pain sometimes. Right, swapped it over for a brand new one. Let's see if we can get through the skin, which stainless seems to develop if you're not really cutting and only just kind of rubbing. What a bitch. Come on. sure that's not a recommended technique to waggle the drill around, but it seems to be getting it to bite in. Right, I really want to open these up a bit bigger than this. I'm putting them there as guides because when I cut this, I'm thinking I'm going to go maybe halfway through from this side and then flip it over, and then the holes will be my guide. I can run a line across. Heavier, slower drill for next size up. Oh, that's going to be stuck. Cool. We've taken the edge off that drill already, have we? Oh my word, look at that. Oh dear. Oops. That was as it broke through and jammed up that done that. Oh hum. It's no good either, crikey. Well, I hope I've sharpened this drill that I chipped earlier. I think we'll try a little bit of, not that it's hot at the minute, but it might help. This is going to be oh my word. Yay! Wow. Okay, drilling done. Going to have a go at cutting some big holes here with a hole saw. That's going to be fun. I'm not going to do that with a pistol drill, that's for sure. So I'm going to leave that until this main piece is cut out. I can do that on a pillar drill. Fingers crossed.